What, if it says many, and what do you think odds are? Yeah. I'm sorry, I couldn't hear you.
I have a question, but you didn't.
No, go ahead. What do you got?
Why was that I know the thing where it's like cosine and inverse.
Yeah. Why haven't we gone over that? What do you mean? Like,
I don't know.
we will. The trig stuff does come back in probably a little bit more towards next week. It comes back again, and we will review it again when we start using it again next week. Right now, we switch away from it for right now, but we'll come back to it and revisit it. I have also, there's been so many people absent lately. That's why I have so many quizzes that I'm trying to get people to take before I can get all that stuff back to you. That's the thing. That's probably also why you're like, we're looking for your old stuff. That's the other thing that's just taking forever to get people to, stop being sick. But what we're looking at here, polygons, is Greek for many sides. So think of this as many-sided figures. Okay? And one of the polygons that we looked at, first of all, one that we spent most of the first semester on and beginning of this semester we're just with triangles. A triangle is a polygon. Polygons there's two types. There's either concave or convex. We have concave versus a convex. Concave have sides that point inward, kind of, think of it as caving in. So that's a polygon. It's a many-sided figure, but it has one side that moves inward. Okay? So that's called a concave polygon. Whereas everything else, doesn't. So when you think of a convex polygon, that's more of the traditional, oh look, it's a square. Oh look, it's a triangle. That's your standard boring stuff, okay? The concave are the ones that have some part of them that move inward. You don't see it very often. We don't work with them all that often, the concave stuff. You will see like I know that on the ACT, they do that. They put a concave polygon in there to work with angle measurements, but it's still a sided figure. You can still figure out the right angles for it. But I'll show you that here in a second. So concave, convex. Concave has stuff moving in, convex doesn't. It's about as easy as you can get it. Types. Types, polygon. I was thinking about St. Patrick's Day, because with this 70-degree weather, that just means it will have a foot of snow on St. Patrick's Day. So I thought I would write it as type O, like O'Toole, a little apostrophe. Irish things, O'Sullivan. Okay. A lot of Irish names have an O in front of them. What's that? O'Brien, yeah, things like that. It's like how there's a lot of Hispanic names with the tilde. Nunez. It has a little N-Y, a little on there and all. Whereas Irish, we have O'Brien, O'Murphy, O'Connor, or O'Shaughnessy. Let's see how Irish we can make it. My ancestors, when you guys have all had history classes before, right? Where the Irish used to be persecuted and nobody liked the Irish back in the 1800s, stuff like that, 1700s. What they did is they had the O, it was O Murphy, so they got rid of the O so they sound less Irish. Literally. What is it? Really?
Yeah, and then when they were Polish, when it came over here.
They truncated it out and made it sound better. Hey, how many sides is this? Or, I'm sorry, what is this called? Triangle. 3 sides are called a triangle. We know that.
What is a four-sided figure called?
Quadrilateral.
That's next.
Four-sided figure is a quadrilateral. Shh, enough. What's a five-sided one called? Pentagon, very good. The reason why I'm going over these is because you will be held accountable if I say, hey, you have a pentagon. You have to know how many sides there are. What is the six-sided figure called? The hexagon. Can I slide this up some? I don't want to get too far ahead of you guys. I'll miss it. Don't worry about trying to draw them. Right about now is when I usually give up drawing because, well, not good at it. So I'm going to press a button because it's easier. So if you have a button, go for it. Not, look at my beautiful drawing. The six-sided one again is called it's the hexagon. The most evil thing in the world from IKEA. You have to use the Allen wrenches to put everything together. What's that? Have you ever gotten anything from IKEA like the Schrufenrinnen or the Forfenrinnen? No. Okay. Well, it's all Swedish, so the Swedish have the Swedish names for their stuff, and it's called the Schrufensiver. And when you put the Schrufensiver together, it comes with an Allen wrench. You know what an Allen wrench is, right? An Allen wrench looks like this. And it's shaped as, it has a hexagon. And you use the little Allen wrench to tighten all these little bolts for your Schrufensiver or the Grubernerven, so you can build a shelf and things like that. They're awful. A seven-sided, let me get ahead of myself here. A seven-sided figure. There are two names for a seven-sided figure.
Why is there such thing called seven-sided?
Well, because there's seven sides.
Is it used like?
I don't know. I don't know. It is called either a heptagon or septagon. It has two names. One is called a heptagon, the other is called a septagon. You have hexagons all over your folder. I completely forgot what an eight-sided figure is called, so stop me if you've heard it before. Stop me if you've heard it.
What?
Oh. I still don't know. A stop sign.
Oh. I was confused.
You're not gonna go with driving.
Oh, and if it's bordered in white, it's optional. Yes, ma'am. A what? It is. A nine-sided one is called a nonagon. Hmm? What? Ah. Now it's not going to be a circle. Can I go up now? We okay?
Yeah.
Don't worry about, like I said, don't worry about trying to draw these things. Just know that it has that many sides. A nonagon has nine sides. Now, Mackie, you were talking about becoming circular. Now, what happens here is I want you to see, yes, as you put more and more sides together, the shape is starting to look more round-ish. But the difference between any polygon versus a circle is that a circle is always a set of points that are all equidistant to a center. Every spot on this, every distance from here to here is all the same. Whereas if you are in a polygon,
the distance from the center from here to here is different than it is from here to here. So polygons, no matter what, you're always going to have at least 3 sides somewhere. So you're going to have all these different lengths throughout. Hey, what is a 10-sided one called? A what? A decagon. As in decade. Get it?
No.
What about 11? I think it is an onagon. I think so, but we don't call it that. We call it an 11gon. Yeah, they got kind of lazy at 11. Said, oh, look at that. It's got 11 sides. That's weird. And they said, hey, let's just call this an 11gon. What this means is that it's called an n-gon. An n-gon, where n is the number of sides. And you usually use that for anything but 11 or more than 12. So if it's 37 sides, it would be called a 37gon. A 432gon would have how many sides? You're both right. So the last one that you will be held accountable for knowing is the 12-sided one, which is not called a 12gon. It's not a clock-gon. Okay? It's called a dodecagon. It's a dodecagon. Yes. 2 plus a decagon. Dodecagon. Okay. It's a Rayloagon.
It reminds me of like the.
Yeah, the next will be 13gon, 14gon, and so on and so on and so on. Okay.
What about hundreds? 100 different?
Nope, 100gon.
What?
They got lazy. They only really named 8 of them. No, I wasn't there. I'm old, but I'm not that old.
Can I actually go? I gotta pee.
I feel so left out. I mean, wow.
Interior angle sum. We don't deal a lot with side lengths quite yet. We'll worry more about side lengths later on in chapter. But for now, I think it's 11. But for now, what we do is we worry more and more about the angles. So what I want to do is just kind of put a couple of these together real quick, just to show you guys what's going on. Okay. So here's what I want to think of. How many degrees are on the inside of a triangle? There's 180 of them. Has that ever changed? No. So I know that inside of a triangle there are 180 degrees. Well, as I go through this, how many, well first of all let me ask you, how many sides are in a triangle? Okay, so that's 3 sides, 180 degrees. This is the quadrilateral, because there's 4 sides. How many non-overlapping triangles can I draw in there? 2 of them. Here's what I mean by non-overlapping. I can do that, but if I split it again, now triangles are overlapping with one another. That's why we talk about what's called non-overlapping. What's 180 plus 180? I don't want to let go because I don't want you to fall. Really bad? Get him. So, that was funny. How many sides was that? There were 4 sides.
How many triangles fit on the inside? 2. Oh, this had 3 sides. How many triangles fit on the inside? The pentagon has how many sides? 5 sides. Which means, how many triangles will I be able to make that are non-overlapping? 3. 1, 2, 3. There are 3 non-overlapping sides.
Sure. That's cool.
So if I go to the next one, hexagon has how many sides? 6. How many non-overlapping triangles do you wager to guess you'll be able to fit in there? 4. 1, 2, 3, 4. Stop laughing. This is not a funny. What is he doing? You okay? I didn't know. All right. So, how many triangles fit in a hexagon? 4. Can you sense a pattern? What is it?
1, 2, 3, 4, 5.
Okay, knucklehead. Yes, sir. What happens is, in order to figure out the sum of the interior angles, so the interior angle sum is always equal to the number of sides subtract 2 times 180. The reason that we use that, the reason we do that n minus 2, because that allows you to figure out how many triangles you can fit in. Okay? So a 7-sided figure, a heptagon, that has 7 sides. How many triangles will fit? 5. So 7 sides, you get 1, 2, 3. There are 5 of them. How many in an octagon? 6. How many in a decagon? Decagon. 8. So if this is n equals 8, there are 6 triangles. If this is n equals 10, there are 8 triangles. So what we'll be able to do here, guys, is that you're going to be able to find the interior angle sum. The reason that we do that is because you will see algebra-style problems like this. These really wind up to be kind of like a build your own algebra problem. Don't draw all that out, but what I want you to, if you have 6 angles, how many sides should you have? 6. The number of angles and number of sides are always going to be the same, okay? So if I look at this, we have, it's a tough thing to count. Ready? 1 little, 2 little, 3 little angles, 4 little, 5 little, 6 little angles, 7. There are 7 angles, which means there are
7 sides.
SMRT. So if my 7 part of the show. Anyway, so if you have 7, hey Tuna, that means I take 7 minus 2. And what do you get? You get 900 degrees. I didn't hear you.
Well, say it loud.
Okay? Now,
Yeah, sure.
that means all of these have to add up to equal how much? 900. What's x plus 2x? 3x. So basically what you're doing here, guys, is you're creating your own algebra problem. And what I'm putting in here is all of these.
That's a lot of work. Do I have to do that? Okay.
All right, so all you're doing is you are going to be creating your own algebra problem. You count the number of sides or angles, it's the same amount. In this case, there's 7 of them.
All the ones on the inside of the figure have to add up to equal then this 900. Okay? Does that make phone calls now? It'd be a lot funnier if it was a banana, because then I would really laugh. Hello? I'm monkeying around in geometry right now. That was great. I'm sorry.
I'm laughing.
So, really, in all honesty here, guys, this is a lot of just build your own algebra. Okay? It's you've done this problem before. You had to do it in triangles. You just had 3 of them. You always do it add up to 180. Okay? It's the same problem. Oh.
So are we just setting it up?
I don't think I need to show you how to press button on a calculator for a two-step equation, right? I hope.
No, I'm saying are we setting it up?
Yeah, that's, you would just solve it from there. I was just showing you how you set it up. Okay. Exterior. Are exterior angles on the inside or on the outside? They're on the outside. So if I go back to my drawings here, exterior angles would have been these.
No, you weren't. I just did those.
As you're looking at exterior angles are the ones around the outside of the object. Well, if I start here and work my way around, how many degrees do I go?
180. I meant.
Did you get the wrong number by chance on that last phone call?
Yes.
Oh, I guess so.
Hold on, I'm gonna phone a friend for you. Hello? What's going on? Let's try.
I'm crying.
I'm sorry, this is perfect. So once again, how many degrees does it take you to get around an object? 360. Because, here, stand up for a second. Stand up, this is funny. Don't stand up. Come on. Go on, come on. Guys, stand up. Turn all the way around. How far did you go?
180.
Wait, hold on. Let's phone a friend again here. How many degrees did you go?
I just did it.
How far did you go?
Oh my goodness.
So hold on. How far did you go when you turned all the way around?
360 degrees.
Because if you just went 180, you just would have went like this, said, "Ah, screw you, Murphy. I'm not talking to you anymore," because you turned your back on me.
It was a joke, just like how your SMRT little thing.
Oh, I'm sorry, I missed it.
Um,
I got to phone a friend for myself. That feels sad.
What if you actually put this whole phone number?
Yes, my phone number is 565. I was the 565th person to get a phone number. Anyway, so if I go to the next one, how many degrees does it take to get around a quadrilateral, do you think? You just didn't want to say it out loud. How many on the next one, do you think? How many degrees does that have to go all the way around something? Again. So what I'm getting at here, guys, is no matter what, to go around an object, the exterior angles will always add up to equal 360, no matter what it is. Whether it's a triangle, a decagon, whatever. The sum of the exterior always equals 360 degrees. Okay. Okay.
Wait.
Now, there's another definition we gotta look at here. It's called regular. We did this before when we talked about equilateral triangles. When we had an equilateral triangle, what made that special? All the sides and all the angles were all the same. So an equilateral triangle is what we call a regular polygon.
regular polygons all sides are congruent and all angles are congruent. Okay? Regular polygons have all the same size angles and they have all the same size sides. Okay? Now when we did that with triangles, we called it an equilateral triangle. Equilateral triangles, we knew that the interior angles had to add up to equal 180. And then what we did to figure out each angle, we divided it by the number of angles, 3. So that's where we got 60 degrees for each one of them. Now, what I want you to think about is that if you take, to find the measure of an interior angle in a regular polygon, now, excuse me. Let me show you an example. Eight-sided figure is an octagon. Are we okay with that? Now, if I wanted to figure out, if I said that this was a regular octagon, that would mean that all of my sides measure the same and all of these angles would measure the same going all the way around. Well, how many angles are there? 8, because it's the number of sides. So there's 2 ways to solve this. One way is to figure out how many total degrees there is, the n minus 2 times 180. And then I would have to divide that by the number of sides. Well, that's the generic way to do this. In this example, I would have to type in my calculator, fraction bar 8 minus 2 times 180 divided by 8. My calculator would do that for me. It's a very generic way to do this. So this is called find measure of interior angle in regular polygon. There are 2 ways to do that. First way, n minus 2 times 180, divide that by n, and that'll equal each one of them. Okay? That is a very, very formulaic way of doing things, but there's an easier, there's a way that I think is easier because it's a little more conceptual. It's a little bit easier to draw and visualize instead of being very fill in the blanks on a formula. Okay. Now, can I go to a clean one real quick? Well, I'm going to. Are you guys okay with the concept idea that in every single polygon, no matter what, there's going to be at least 3 sides? Okay. Now the other thing is, at some point in time in a polygon, those 3 sides are going to be connected somehow, some way. Now, if you disregard the idea of the quadrilateral and the triangle, you're always going to have this sort of visual where 2 sides or 3 sides intersect. You have 3 sides and you have 2 angles in between. I use this diagram a ton. I use it all the time. Now, if I know that my number of sides is 8, it's always quicker to find the outside angle. Because if you have 360 degrees going all the way around, each outside angle would just be 360 divided by 8. Okay? It's always quicker to work on the outside. So if I take 360, divide that by 8, you get 45. Interior and exterior angles form lines. They're linear pairs, which means the supplement of 45 is the inside. And you get 135. So the other way to do this
The other way to do this to find the inside angle on a regular polygon is to work formulaic, or just get the supplement of the exterior angle. The supplement of the exterior angle is the inside angle. It's just a lot quicker. It's always quicker to do that than the other way around. Okay? All you need to do is find that outside angle. And it's always faster to find the outside because you just take 360 divided by however many sides there are. It's always quicker. Okay? Either way works. It's just a matter of what are you more comfortable with trying. Okay? Let me show you an example. If I want to find if I want to find the measure of the interior angle of a regular 15 gon, how many sides are there? 15. So somewhere along the lines, 3 sides we're going to run into each other. I know that there's 15 of them, which means the outside angle will be 360 divided by 15. Tope, you just type that in, what'd you get? What was it? 24. So if the outside angle is 24, what's left then to form into 180? There you go, done. Yep. Remember, to get the measure of the interior, take 180, subtract that 360 over 15. That's all you're doing. You're working on the outside in. It's always quicker. You can do it either way. It's just a little bit easier to work on the outside in. Okay? Not terrible? Okay. Well, switch it up then a little bit.
Are you gonna give us like worksheets instead of like doing on paper?
What do you mean?
Like blank paper so we don't like draw anything out?
A lot of these start with, the way that I'm showing you the little shortcuts of drawing the 3 side part, that's the easiest way to do it. Now, there are, I mean, eventually you're going to have, I mean, some homework stuff tonight, it'll have stuff like this, but you can just draw, or you just have to write it down because it's just in the problems out of the book. Okay? But most of these things, like, that you start, like, you don't have to draw it, don't have to draw. But if you need to know that you're trying to find the measure of, of an angle part, just do that and work your way out of it. Okay? So if I want to find the measure, excuse me, in this case, I want to figure out the number of sides. If it's a regular polygon and the inside angle is 108, what's its outside angle then? If the inside angle is 108, what's the outside angle? 72. Good. Now, we know that if I take 360 divided by the number of sides, it gives me my outside angle. 360 divided by number of sides gives you outside angle. Well, in this case, my outside angle is 72. That's fraction equal fraction, isn't it? Because what's the 72 over that you don't see? 1. What did we do whenever the variable was in the denominator? We could cross multiply. What did I always say though? Exchange-o, change-o. You're still doing that. You exchange-o, change-o. So 360 divided by your outside angle gives you number of sides. In a regular polygon, 360 degrees divided by the measure of the outside angle equals number of sides. This is a nice little shortcut to remember. Okay, what's that? Pop. Oh yeah, wait, what, huh? Yeah, you're actually doing math. So what happens here, guys, is that you're gonna be working with, well, it works out to be like 4 or 5 different formulas, really. They're all kind of an offshoot of one another. They're not very different. It's a matter of knowing what information do you have and what information you're trying to show. Okay? Excuse me. If each interior angle is 144, how many sides does it have? This is for a regular polygon. You have a regular polygon, and each interior angle is 144. What do you get for the number of sides? Remember, same basic idea. I don't know how many sides there are, but I do know that this one here is 144, which gives you a 36 on the outside. Yeah, it's 10. You take 360 divided by your outside angle, and you get the number of sides. I sense sarcasm in your tone. Yes, ma'am.
Where does the 36 come from?
What's that?
Where does the 36
If the inside angle is 144, remember the outside angle would be its supplement. So the supplementary, the linear pair, if you want to think of it that way, what 144 plus what is 180? So that's what we're using those things from. Okay. We use supplements and things like that a ton in this stuff. Okay. Because it's always easier to work with the outside angles. It's less math. All right. I'm assuming none of you guys remember how to find your way to the book. So as a refresher here, I will show you guys in a second, once we get this saved up here, and I'll write this on the board as well. Yep, it's on the website, it's for the book. So it's what, 510, we have 5 through 8, 11, 16, 19, 21. Just a quick reminder then. Mackie, would you get the light real quick, please? Just a quick reminder. Guys, it's been a while since we've had to use the book. I haven't used the book, I think, this entire semester so far. We are in Chapter 8. So you click where it says Chapter 8. I don't know. Where do you think I might wind up having to click for the textbook?
Right there. Whoever. Definitely go up there and look at the whole
Oh, no, but it says Chapter 7. Murphy, this is Chapter 8. Well, if you click on Chapter 7, it opens up. You might have to scroll to get to Chapter 8. Because remember, these books are done in...
2 chapters apiece.
Yep. So there's your 8 stuff. Okay? Just a reminder of how to get there. Get those done for tomorrow, and we'll go on from there. Would you get the light back up for us, please? Thanks.